Hi guys, today we're going to be speaking about redox reactions. So welcome everyone, today we're going to be talking about the fascinating topic that affects our daily lives in more ways than we can imagine, redox reactions. But what are they? In simple terms, they involve the transfer of electrons between molecules or atoms. Now I know this may sound a bit technical, but bear with me. Understanding redox reactions is crucial for our understanding of how the world works. Redox reactions, short for reduction-oxidation reactions, involve the transfer of electrons between molecules or atoms. Simply put, oxidation is the loss of electrons and reduction is the gain of electrons. An easy way to remember this is through the mnemonic oil rig. Oxidation is loss, reduction is gain. For example, when iron rusts, it goes under oxidation because it loses electrons, while oxygen undergoes reduction because it gains electrons. Another example of redox reaction is the combustion of methane gas, which produces carbon dioxide and water vapor. In this reaction, methane is oxidized because it loses hydrogen atoms and gains oxygen atoms, while oxygen is reduced because it gains hydrogen atoms and loses oxygen atoms. So what are some types of redox reactions? Redox reactions can be classified into four main types: combination, decomposition, displacement, and combustion. In combustion reaction, two or more substances combine to form a single product. For example, when iron reacts with sulfur to form iron sulfide, it is a combination reaction. The equation for this is Fe plus S gives you FeS, iron sulfide. In a decomposition reaction, a single compound breaks down into two or more simpler substances. For example, when hydrogen peroxide breaks down into water and oxygen gas, it is a decomposition reaction. The equation for it is 2H2O2 plus 2H2O plus O2. In a displacement reaction, an element in a compound is replaced by another element. For example, when copper wire is placed in silver nitrate solution, the copper atoms replace the silver atoms in the compound, forming copper nitrate and silver metal. The equation for this reaction is copper plus 2AgNO3 gives you copper NO32 plus 2Ag. In a combustion reaction, a fuel, usually a hydrocarbon, reacts with oxygen gas to produce carbon dioxide and water vapor. For example, when methane gas, CH4, burns in the air, it produces carbon dioxide and water vapor. The equation for this reaction is CH4 plus 2O2 gives you CO2 plus 2H2O. So now how do you balance these equations? Balancing redox equations is a crucial skill for anyone studying chemistry. It involves identifying the oxidation and reduction half reactions, balancing the atoms, and balancing the charges using electrons. One useful tool in this process is assigning oxidation numbers to each element in the equation. This allows us to track the transfer of electrons and determine which elements are oxidized and reduced. For example, consider the reaction between iron and chlorine gas to form iron 3 chloride. The oxidation state of Fe changes from 0 to plus 3, while the oxidation state of Cl changes from 0 to minus 1. By assigning these oxidation states, we can write the half reactions. Fe gives you Fe3 plus 3 electrons, and Cl2 plus 2 electrons gives you 2 Cl minus. Balancing these half reactions and adding them together gives us the balanced redox equation. 2 iron plus 3 chloride gives you 2 iron chloride. What is the application of redox reactions? Redox reactions are not only important in chemistry, but they also have many practical applications in our daily lives. One such application is corrosion, which is the gradual deterioration of materials due to chemical reactions with their environment. For example, iron rusts when it reacts with oxygen in the presence of water. This process can be slowed down or even prevented by using coatings or sacrificial anodes that undergo redox reactions instead of the metal. Another important application of redox reactions is in batteries. Batteries work by converting chemical energy into electrical energy through a series of redox reactions. For example, in a lead-acid battery, lead dioxide and lead metal undergo redox reactions to produce lead sulfates and water, generating an electrical current in the process. This technology is used in cars, cell phones, and other electronic devices that require portable power sources. Finally, redox reactions play a crucial role in metabolism, the set of chemical reactions that occur in living organisms to maintain life. For instance, during cellular respiration, glucose is oxidized to produce carbon dioxide and water, releasing energy that is used to power the cell. Similarly, during photosynthesis, plants use redox reactions to convert sunlight into chemical energy in the form of glucose. These processes are essential for life as we know it. In conclusion, redox reactions are a fundamental concept in chemistry that involves the transfer of electrons between atoms. We learned about the meaning of oxidation and reduction, the different types of redox reactions, and the process of balancing redox equations using half reactions and oxidation numbers. It is important for grade 10 students to understand the redox reactions because they play a crucial role in everyday life, from the corrosion of metals to the functioning of batteries and metabolism. By understanding redox reactions, students can apply their knowledge in real-world situations, make informed decisions about the world around them.